All right, guys, so the question is 1 equal to 0.999 repeating? This was in a post that I was tagged in on Facebook, and I'm going to attempt to, not even close to the best of my ability, to show you that it is. What I want you to keep in the back of your mind is there a number between 0.999 repeating and 1? Those are less thans, and that is an x. Those are not L's. Elementary algebra, x equals that. 10x equals that. Decimals move when you multiply by 10. Lo and behold, subtract those two. 9x equals 9.0 repeating. Divide by 9. X equals 1.0 repeating. Here's another one. 1 minus that equals zeros repeating. But elementary algebra doesn't deal in the infinite case. When you carry out zeros, is there a 1 hanging out way far back there? Somewhere in the thermostat? I don't know. That's what this is for. You would see this probably somewhere in Calculus 2, definitely in real analysis. Let's set this sum, S sub n equals to that. This is essentially what this is when it looks like a sum. Dot, dot, dot means forever, how long ever you want it to go. 9 over 10 to the n plus dot, dot, dot. Fancy notation. That is a sigma, and that is a k. Here's the sequence again. The sum again. Same thing. That is a 1 over 10 to the 0. Anything to the 0 power is 1. 1 over 1 is 1. 1 times anything is that anything. 1 over 10 to the 1, 1 over 10 to the 2, 1 over 10 to the 3, dot, dot, dot. 1 over 10 to the n minus 1. And yes, it does go further than that. Let's multiply by 1 over 10. So 1 over 10, 1 over 10 squared, 1 over 10 cubed, dot, dot, dot. 1 over 10 to the n. Subtract those two. The only two terms left from these two above here is 9 over 10 and 9 over 10 times 1 over 10 to the n. Factor out an s, factor out a 9 over 10. Divide by 1 minus 1 over 10. That's what you get. Fancy algebra. Fancy algebra. Now, let's deal in the infinite case here. Infinite amount of 9s to write. Not that the number goes to infinity, even though it might, I don't know yet. Let's take the limit as n approaches infinity. 9 over 10 times 10 over 9 is a constant. N is not in there, and it's not going to do anything as the number grows substantially larger, that number being n in this case. Minus 1 over 10 to the n. That number is going to approach 0, and an infinitely large n, you're going to get 0. Thus, it equals 1 in the infinite case. Now, the question is there a number that exists between those two? I just showed you several ways where there was not. Evaluating rigorously in the infinite case that there's not. This is the real number line, or is it? You see numbers that you're very, very familiar with. You see the square root of 2. You see e. You see pi. You see 3. You see 8675309 plus pi. Jenny, I got your number and some pi. Are you going to come over and watch Netflix? Again, the question is there a number that fits between those two? These are the integers. You're very familiar with those things. They go out to n, however far you want. Using this, the compactness theorem, you can generate sets that are outside of that, infinitely larger. K is infinitely larger than everything over here. Negative b is infinitely less in value than everything over here. That means that if you divide k, if you reciprocate k, 1 over k, that is infinitely small. It's smaller than anything on here. And nothing in between these will actually approach it. And it will end up here. That means that there is a set that exists here of infinitely small numbers, and that set is infinitely, countably, or not countably, infinitely larger, the amount of numbers in the set, than everything on here. And those are called monads.